Hey guys, we're gonna do a sampling distribution for difference of proportions. This is my third time starting this video, so if I go too fast, forgive me, but I'm a little over it right now. I'm gonna do my best, but again, please forgive me if I just, go too fast subconsciously, okay? All right. In one state, 52% of voters are Republicans and 48% are Democrats. In the second state, 47% of voters are Republicans and 53% are Democrats. Suppose 100 voters are surveyed from each state. Assume the survey uses simple random sampling. What is the probability that the survey will show a greater percentage of Republicans voters in the second state than in the first state? Okay, here's the deal, guys. This one is actually a little bit more of a difficult one to start off with, which is why I'm glad that I'm giving it to you. But typically, well, they actually do both. You will see it two different ways. Sometimes you will see, what if the difference is 5, okay, by 5 percentage points. This one doesn't show us any statistic that we're looking for yet, okay? We just want to know now, typically when I set my curve up, you guys, when we're doing our differences, we typically always do P1 minus P2. That's kind of how we set up everything, okay? So P1 would be right here. Where is it? The Republicans. And P2 right here is for the second states, with the Republicans for the first state and the second state. Moreover, if I look at the difference right now, 52 minus 47, that gives us a difference of 5. Okay, that's a positive number. I like to deal with positive numbers in statistics, which is just more evidence to why I set it up as P1 minus P2. Now, you may be thinking, like, what the heck is Miss Opal talking about right now? It's okay, okay? I will walk you through these. I'll do problems as a class as well, but I promise you'll see along the way, okay? What we want to know now is just that probability statement. What are we looking for? I want to know that the probability, if I look at P1 versus P2, and not the parameters, but the statistic, the survey, okay? That's the percentage of people from the survey. We want to know what's the probability that the people from the second state will be greater than the ones from the first state, okay? And because it's from the survey, that's the statistic, so we're going to put a hat over it. Okay, we're going to put a hat over it. So this is what we're looking for. Next, what we have to do is we have to do the conditions. That's the plan. And we have to do it twice because we have 2 samples. We have 100 people that are surveyed from the first state and 100 people that are surveyed from the second state, okay, from each state. We have to do this twice. The first condition is the random. So what sometimes people like to do, and what I used to do, is I would set up this little kind of two-way-ish table. And I would put sample 1 over here and sample 2 over here. And then I would draw these arrows to remind people. I don't do this anymore when I'm actually doing the problem, because we can sum it up a little bit faster by writing it all at once. However, I like this visual because there is a third arrow that we must put with the I, the independence condition. And that third arrow is right here. Samples must be independent of each other, okay? So the first one, random. Do we have random samples? And it states that we have a simple random sample of 100 voters. So an SRS of state 1, N is equal to 100. SRS of state 2, N is equal to 100. We checked both, okay? We have 3 things we have to check. That's that 10N, don't forget, is less than capital N, okay? So 10 times 100 is less than all people in state 1. We have to do it again with state 2. 10 times 100 is less than all people from state 2. Now what we have to do, there's no mathematics involved here. We just have to say samples are independent of each other, okay? And we did that right there. Okay, take a second and pause if I'm going too fast to make sure you have everything down. Write down any questions that you might have, okay? If the probability statement is confusing for you right now, that's okay. I'm okay. Honestly, if you don't have this part, that's okay. And it's okay for the College Board as well, to be honest, okay? We're trying to get you in the habit of the state plan do conclude, because on the next unit, you have to have the state, okay? So, and the state will look just a tiny bit different than what we have here, just a tiny bit. Okay, next we have the normal model. This is a really big mistake that people make. People do n is greater than or equal to 30. That is for means, not proportions. Remember the normal models, n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Okay. You have to do this for both both samples. So I did that right here. 100 times 0.52 is greater than or equal to 10, whoopsie. And 100 times 1 minus p is greater than or equal to 10. I did it down here. So I have state 1 and I have state 2. I've met my conditions. Now I can go ahead and I can set up my model for my sampling distribution for the difference of proportions. When you are asked to describe the sampling distribution for the difference of proportions or the difference of means, okay, for the difference of proportions, our shape is normal. Why? Because our normal condition was met. Our center is P1 minus P2, the parameter of the first state minus the parameter of the second state. And then our standard deviation is the formula right here. We take P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2, and we take the standard deviation of that. Pause the video right now and write down the model for the sampling distribution for difference in proportions. Okay, again, just a friendly reminder. Remember, if you're asked to describe the sampling distribution, you're telling me it's normal, you're telling me what the parameters are subtracted from each other, and the standard deviation. All right, so we have our picture. Let's draw it right here. Oopsie. Forgive me, erase this. It's from another period, another time. Okay, we're gonna take P1. So P1 is state 1. Okay, so state 1 is 52%. That's 0.52 minus P2. So that's state 2, 0.47. That gives us a difference of 5%. So on average, there are 5% more Republicans in state 1, right? P1 minus P2, on average, there are 5% more Republicans, because this one is state 1, this one's in state 2, in people in state 1 than in people in state 2. Okay, so that's what that means. You need to make sure you understand that. Now the standard deviation. Okay, P1 is 0.52 times 1 minus 0.52 over N1, which is 100. I need to do it again with P2, and I'm going to add that. So I'm going to take 0.47 times 1 minus 0.47 divided by 100. And now what I need to do, I'm going to round to 4 decimal places, and I'm going to type this in my calculator. I want you to pause right now. I'm going to pause as well, get everything all set, and find out what the... Okay, ladies and gentlemen, I got 0.0706. I'm not going to double check it, so I'm crossing my fingers. I typed everything in my calculator right. I'm going to get shade here from you guys, from people on the internet. Okay, next thing that we need to do, we have our picture. Well, in our picture, we always have our mean, we have our standard deviation, but we also need our observation. Okay, that means we need our statistics. Okay, what's going to happen in our sample? Well, we're interviewing 100 people, right? So P hat of 1, we're interviewing 100 people, and we're going to have a part of it, right? And we're interviewing people from state 2, and we should have a part of it to give us our statistics, right? And then what we would want to do is we'd want to subtract it normally. But there's an issue with this. They don't tell us the parts of the total sampled to get these P hat of 1 and P hat of 2. So typically you'd take your P hat of 1 and your P hat of 2, and you would mark where that is on here. That would be your observation, but they don't give us that. What do we want to know, you guys? Well, P hat of 1 minus P hat of 2, that's what we typically do, right? These are the Republicans from state 1, and these are the Republicans from state 2. On average, the Republicans from state 1 they have more by 5% on average, okay? Sorry, my language didn't sound great there, or my grammar, excuse me. We want to know the probability, okay, of when the proportion from state 2 that are sampled is greater than the ones from the proportion of state 1, which means this P1 has to be smaller and this P hat of 2 has to be bigger. When the proportion from state 2 is bigger than the proportion from state 1, we would get a negative number. Normally, it's a positive number on average. Normally, there's more Republicans from state 1, but that's not what the question's asking. It's saying, when will it be greater from state 2? Or what is the probability it will be greater from state 2? Okay, so we have a number line here. We could ask 100 people from state 1 and 100 people from state 2, and we could get something over here. That's going to be a positive number. That's greater than 5%. Okay? We could get something over here. That still looks like it might be a positive number, right? Based off that standard deviation. At what point on my number line will the Republicans from state 2 be larger? They'll be more. Well, that's going to be anywhere where we have a negative number. And that means that's going to start immediately after we hit 0. This is all negative area. Anywhere over here, if we get any observation in this blue area, okay, any observation in this blue area, that's when we know there's going to be more Republicans in state 2 for that sample than state 1, okay? Which is what the question is asking. What's the probability? Okay, what's the probability that based off the survey, we'll have a greater percentage of Republicans in the second state than the first? So in this case, this is my observation. This is my observation. So now I'm going to go ahead and I'm going to find a z-score for that observation. So we have z is equal to 0 minus 0.05 divided by 0.0706. I'm going to go ahead and type that in my calculator. 0 minus 0.05 divided by 0.0706. And that gives me a z-score of negative 0.71. I'm now going to go to my calculator, but I'm going to give you a second to write all this down in case you're behind it all. I did a lot of explaining earlier, but just in case you're a little behind. I'm going to go to my calculator. I'm going to do my normal CDF, so second vars. Normal CDF is number 2. My lower bound is over here, so that's going to be negative 999. My upper bound is going to be my z-score, negative 0.71. I keep mu as 0 and standard deviation is 1, and I go ahead and I hit paste, and I get a probability of 0.2389. That is my p-value. And then finally, I would conclude. I've practiced concluding with you, so to save your time, I'm not going to conclude on these notes. Just remember to keep in mind that use your context, okay? So you would say, instead of saying, what is the probability? You'd say the probability that the survey will show a greater percentage of Republican voters in the second state than in the first state is approximately 0.2389. Now, if they said, would you be surprised by this? What would you say? No, because the probability is not less than 5%. It's a relatively large probability that this could happen. Okay, what should we have learned? What the sampling distribution is, if they ask you to describe. We talked about some differences, okay, and just how this problem was worded, some kind of funny things here, and what you would normally do if they gave you the statistics. You would subtract those and you would mark it. This time they don't give you that statistic, and so they just see if one is bigger than the other. Anytime you have one is greater than the other, you can pretty much assume that your observation is 0, just FYI, okay? Now, I don't have a mean problem for you, and to be honest, I searched the internet, far and wide, looking for like the perfect means problem to do with you. Then I was going to do your homework, and your homework's not that long. So I want you to practice your homework on your own, and I will do the homework problem with you. But at least what I want you to do is I want you to look at the sampling distribution, okay? So what changes when it's a difference of means? First thing that changes is when you're doing your conditions, your R, your I, and your N. You still have the 3 arrows for the I, just like we did over in the proportions. And just remember for the N, it's N is greater than or equal to 30, okay, for both of them. Next, when we're drawing our curve, ladies and gentlemen, really an amazing curve. I know, I'm sorry. Okay. Here we're going to put mu of 1. So that's the given parameter that they give you minus mu of 2. Okay. Next, what we're going to do, and I actually have it up here. I have your formula sheet here so you can see the one for the sampling distribution for 2. Let's see. For proportions. So this is the one for proportions. And then if you scroll down for means, and I'll spend some more time with you guys on the formula sheet. If you see the one for means for 2 populations, we have it right here. So we take the standard deviation squared, and I'm going to take a picture of this actually. And again, we'll spend some time with that, so don't worry about that right now. Here is our standard deviation. Okay, so when you're asked to describe the sampling distribution for the difference of means, you're going to say normal, as long as these conditions are met, right? Normal with a center of mu of 1 minus mu of 2. And a standard deviation, you take the standard deviation of the first population, square it over the sample size, plus the standard deviation of the second population, square it over the second sample size. So first sample size, second sample size. Next, what you're going to do is they will give you an X bar of 1, and they will give you an X bar of 2. Or they may say if one is greater than the other. Remember, if one is greater than the other, your observation is more than likely 0, okay? Or they'll give you 2 X bars. You mark where the difference is. X, you literally find that X bar of 1 minus that X bar of 2. You find a Z-score from there, and then you go ahead and you do your normal CDF. I know some of you may be uneasy because I didn't actually do a problem with you, okay? No, it's literally the same exact thing that we just did. It's just this is how it changes. Just a couple of different changes. That's what statistics is going to be like the rest of the semester. You're going to learn something and then you're going to do a little tweak to it, okay? And really, we're doing Z-scores pretty much the rest of the year. Z-scores or T-scores. T-scores are essentially the same thing, okay? All right, so with that being said, I am done. Try your homework. It's only a couple questions. And like I said, I'm more than happy to go through it with you if you need it.